Hello, I welcome you all to this class. In this video, we are going to learn about the center of gravity or centroid. So, centroid is just a synonym of center of gravity or center of mass. So, centroid is what? The centroid is just a center point of any object, or center of gravity is the point of a body where the gravity can act on a body, right? So center of gravity, you can say it is the point where the weight of a body can act, or centroid is a point where the whole area of a body assumed to be concentrated, right? So or that centroid is a point where the geometric center of a geometric object can act. Now what are the examples, means where we will use the centroid concept or center of gravity concept. So centroid concept will use in analysis of forced distribution, and in case of the beam bending, and also in case of the torsion in the shaft. Now, so some geometrical figure we have to learn, whose center of gravity we have to find, right? And let's say that geometrical figure is a triangle, right? So for a triangle, the center of gravity will lies at the point where their medians are intersecting. Okay, so let's say that you can say first we'll define the center of gravity, right? Center of gravity. Very fast you can write that center of gravity is nothing but it is a point where the whole weight of a body can act, right? Can act. So let's say that this pen is there, right? So where the center of gravity is lying, that if I keep this, means if I'm keeping the pen exactly at the center, so this pen is to be concentrated, means it is not moving, right? So it's balanced. Now if it shift a little bit, then what will happen? The center of gravity, the body is not concentrated, so it means that the center of gravity for this pen is exactly at the center. Now then we have a let's say you can centroid, right? So this is the centroid, right? So centroid is what? It is a point. It is a point where the whole area of a plane figure or object, right, assumed to be concentrated, right? The examples of, means the practical application or engineering application of centroid is that in case of the forced distribution, that how the forces is distributed so that the body is not vibrating and all those things. So if you see the chassis of a four-wheeler, right, so that it will be designed such that the whole weight will act at their center. So first we have to locate the center of that chassis, and then only we will start designing, right? The second case, you can say that in case of your beam bending, when you design the beam in case of the structural engineering or in case of the construction, right? And third one is the shaft torsion, right? Is the shaft torsion. So these are the practical application where we will use the concept of the centroid, right? Now, so centroid, I told you that it's just a point, center point of any object, or it's a synonym of center of gravity or center of mass. Already you learned the center of mass in your class 11th physics, right? So it's just an advanced form of that. It means it's a practical engineering application or industrial application of that particular topic, right? So now we can say that some geometrical figure whose center of gravity we should know, right? So you can say the centroid of few, it's better of few geometrical object, right? Object. So let's say that first we'll begin with the triangle, right? So this is, suppose the triangle is somewhat, it will be typical. So I will give you the two figures. This one triangle is there, right, whose base you can say is B and the height is H. So as I told you that centroid of any triangle is lying at the point where their medians are intersecting. So let's say one median is this, one median is this one, and the one median is this one. So its center of gravity is on y-axis, and for x-axis is this one, right? So if I take this as a x, so its value will be the b by 2, and this will be the h by 3, right? Means for this case here itself that let's come back, the center of gravity is denoted by CG, right? And symbolically you can find the center of gravity of any geometrical figure about their x-axis and about the y-axis. So center of gravity or centroid, symbolically you can represent by x bar and y bar. So for this particular triangle, the x coordinate means the centroid about the x-axis is b by 2, and for the y-axis it will be the h by 3. Okay, and you can say the center of centroid, just wait, yes, centroid of a triangle, this is triangle, right? Triangle lies inside the object, means inside the triangle, right? Okay, now next we'll see the that is, yes, sorry, yes. So next we have a one more point you can make additionally, that centroid of a triangle separates the median, separate the median in 2:1 ratio. This is very important point. So in few competitive exams you can get that centroid of a triangle separate the median in what ratio? 2:1, 3:1, 4:1, 1:1. So your correct answer would be the 2:1, right? Now, so next geometrical, and one more point you can make as we'll move further. So you can say the centroid of a convex object lies inside, means in the body. Convex object example is what? the round table, rectangular table. So these are the convex object example. And next point, you can say the centroid of a non-convex object, non-convex object might have outside the figure. Figure means whatever the object you have. All right, now the next, you can say, we'll try to learn the centroid of a rectangle, right? So this is your rectangle. So it's, you know, the rectangle is like this. Where is that? Yes. So centroid of a rectangle is this one, right? So sorry, rectangle is this is your, you can say, breadth, and this is the depth, right? So centroid of a triangle is a point where their diagonals are intersecting. So this is the one of the diagonal of a rectangle, and this is the another diagonal of a rectangle. So this is the point where the CG is lying, that is centroid, center of gravity or centroid, right? So for this x coordinate it will be here, and for y coordinate it would be here, right? So if I measure this and if I calculate this, so this is your b by 2, just half of the, and this will be the d by 2. So here you can write that centroid of a triangle is x bar is equal to b by 2 and the y bar is equal to d by 2. Okay, now the next geometrical figure which we will learn, that is triangle, circle. So this is your circle. Sorry, I'm very sorry. Yes, now we have to shift actually. See, there is a drawback that most of the time I can't draw the circle in proper fashion. So this is the center of the circle. So for circle, the centroid will be lying at their center, or you can say the radius from the edge of the circle, right? So center of gravity, this is the radius, right? So it is the, let's say the radius is r. Okay, so centroid of center of gravity of a circle is at their center, or you can say the radius from the edge, right? Either x or y, it will be same only right now. So now next we can see the centroid of a semicircle. Very good, that is semicircle. So for semicircle we have two cases. That semicircle, either it will be kept horizontally or it will be the vertical, right? So first I'll show you that. Let us imagine the semicircle is kept horizontal, right? So it means that this is the center of the semicircle and it will be the radius. So in case of the horizontal, that x coordinate means x bar, center of gravity or centroid of a semicircle is their radius, right? And for y, it is the 4r by 3 pi. 4r is the radius and pi, you know. Now the next case is what? That next case we have just hold on. Yes, sorry. Now the next case is what? That centroid of a semicircle itself, but this time we are keeping the semicircle in this manner, right? It means it is kept vertically, right? So when it is vertically, its y coordinate will be their radius itself. This will be the radius, right? From here to here, means this you can imagine, right? This is not imagine, it is the exact radius. So for y bar, it is the radius itself, but for x coordinate it will be the just reverse 4r by 3 pi. One more figure we just now I remember that this is the quarter circle, right? Quarter circle. So your quarter circle will be like this. It is an arc, right? So for quarter circle, x is equal to y is equal to 4r by 3 pi, right? And area of the quarter circle, you know, that is area is equal to pi by 4 r square, and for the semicircle the area is equal to pi by 4 r square. This is the additional I have. Even that's just that, you know, right, as you are the engineering student, so you must have this idea. Now that then the question is arising that how can we find the centroid of a plane figure or of an object, right? So the analytical method we are going to learn to get the centroid of a plane figure, right? So you can say the analytical, make a heading that analytical method to calculate the center of gravity. Center of gravity is the CG. Let us say that we have a XY plane is there, right? Very carefully you'll draw that this is your X and this is your Y, right? And this is your origin. Now then in this plane, that is in XY plane, we have a one plane figure is kept. This is of any shape you can assume, right? So this is the plane figure whose center of gravity we have to find about x and about the y-axis. So let us say that first we are considering the area of this plane figure is A, right? So area of the plane figure we have assumed that is A, and now you can consider this a plane figure is composed by number of areas A1, A2, A3, so on, so, right? So let us consider that this plane area is composed by number of areas. Let us say this area is A1, this is A2, A3 and A4. How many part is given? That part you can imagine. Then while we finding the centroid or center of gravity about x-axis, the reference should be the OY, and for y-axis the reference should be the x-axis. It means that horizontal distance you have to measure, right? So horizontal distance you can get only when your reference is the vertical axis. So let's say that the area A1, or then this, as this area is A, is composed of A1, A2, A3. So the total area A is equal to what? The total area A is equal to A1 plus A2 plus A3 plus A4. All right. Okay. Now then we can consider that this area A1 is at a distance of x1 from the OY axis, and this area A2 is at a distance of x2 from the OY axis, and this area means A3 is at a distance of x3, and let us say here itself this area is at a distance of x4, right? Now then you can find that center of gravity about x-axis is equal to that center of gravity, sometime it also known as the first area moment. See, all points we cannot say at the beginning itself, right? So now I am telling you that center of gravity of a is also known as the first area moment. First area moment means what? Area into distance. So x bar is equal to, we can say, the A1 x1 plus A2 x2 plus so on, so An xn. That how many part means that plane area is composed of n number of part. Let us imagine. So this is A1 plus A2 plus so on, so An, right? So you can find, say that x bar is equal to summation of I running from 1 to n ai xi upon summation of I running from I running from 1 to n ai. So this is the empirical relation by which you can get the center of gravity. So this is the way, means just you have to find the area and the distance of that area from the y-axis, their product by that area. Okay, now similarly you can say for y-axis, how can we get? So let us see that just hold on, that this is your here for y-axis. Now for y-axis, let us imagine that let us consider that this is the xy plane, x-axis, y-axis, and this is the origin. Now again we can consider that we have a plane area of any shape, right? So this area is having a, the plane area is having a plane figure is having area is a, sorry, that is a, and this is composed of number of areas, that is a1, a2, so on, so an. So but for y coordinate we have to use the x-axis, the reference will be the x. So it is this one, a1, a2, so on, so an, a3, a4, whatever, so right. So now that area is what, this a1 plus a2 plus so on, so an, number of part is there. Then let us say this area is a1, this is a2, this is a3, let's say this is an, how many part is there, right? So this area a1 is located at a distance of y1 from the ox axis, and this is located at a distance of y2, and this is located at a distance of y3 from the ox axis, and this is located at a distance of y4 from the ox axis. Now so y coordinate is what? Y coordinate is a1 y1 first area moment plus a2 y2 plus so on, so plus an yn upon a1 plus a2 plus a3 plus so on, so plus an. So this is your relation, and in mathematical form you can write further that y bar is equal to summation of I running from 1 to n ai yi by summation of ai, that is I running from 1 to n means what? That how many n is there, that is how many plane area is there. So this is how we will solve the problem. So in next class we are going to solve the problem related to the center of gravity. Thank you.